formulas have another interesting characteristic, and it's to do with the sequencing pattern that is generated by quadratics. So if we take a look at the quadratics, we have x equals 0, y equals 1. So basically we're just squaring our x coordinate to get our y coordinates here, and we get our quadratic shape here. Now there is a pattern in the differences or the changes in y. So if we take a look at this here, there's a plus going from 0 to 1, it's plus 1. Going from 1 to 4, it's going to be plus 3. Going from 4 to 9, it's going to be plus 5. So the pattern looks like this. So it's plus 1, plus 3, plus 5. To go to 16, we're going to go plus 7. 25 is going to be plus 9. 36 is going to be plus 11. So there is a pattern in the changes of the y. In fact, the pattern of the changes, the change in y, is linear. And when we look at these changes, it's really important to start looking at these changes because this is what calculus is all about. When we start getting into calculus, we want to look at the changes. So going from a quadratic, the changes in a quadratic is linear. And that's a fairly important concept later on. So right now it's just interesting to look at the patterning. But that principle is actually very fundamental when we look at a little bit higher level math. And in fact, we can come up with an equation for these changes. And the equation for the change in y is linear. It looks like it has a slope of 2. Okay, so it's going to be 2x. And if we go with this x coordinate here, we'll go 2x minus 1. Okay, so when x is 1, y is going to be, the change is going to be plus 1. So what we can do then is we can look to see if something is quadratic based on looking at the changes. So if I look at this pattern here, okay, we can look at the changes in the pattern. Okay, so when I look at from -3 to 0, it's going to be plus 6. From 0 to 3, it's going to be plus 6. From 3 to 6, it's going to be plus 6. When we have a linear function, the changes are constant. We'll go up by the same amount. We have the same slope. So graphing this -3, -4, 0, 2, 3 over 8 up. Okay, we have a linear. This is the original function. I draw this in a different color. The original function is linear. Okay, and the changes are constant, right? It's always going to be plus 2, plus 2, plus 2. And in fact, when we write the equation of the changes, it's just a constant. Y equals 6. So going from a linear function, the change is going to be constant. And this is something we've seen before. It's just constant slope. Okay, so we can determine if a function is linear or quadratic by just looking at the changes.